Hello friends, subscribers and new viewers of this channel, and welcome to C++ tutorials for robotics, machine learning and control engineering. In this C++ lecture, we provide a concise tutorial on linked lists in C++. In particular, we explain how to number 1. Define a linked list. Number 2. Develop minimal C++ code that implements a linked list. Number 3. Manually insert entries in a linked list. Number 4. Print the entries of a linked list. In the other parts of this tutorial series on data structures and algorithms in C++, we will explain how to perform more advanced operations on linked lists. Note that in this tutorial, as well as in other tutorials, we keep the implementation of linked lists as simple as possible in order not to blur the presentation with too many C++ implementation details or advanced C++ concepts. The implementation is not optimal and not completely robust. However, it is simple and consequently it enables a student to understand the basic concepts clearly. But before we start with the presentation, here's the copyright notice. This video lesson, developed code files and documents should not be copied, redistributed, or posted on public or private websites, public or private code repositories, or social media platforms. This lesson and all the provided study materials are strictly for personal use. Without the permission of Dr. Aleksandar Haber, this lesson and the provided materials should not be used for commercial purposes and for training of engineers working in companies. This lesson and the provided materials should not be used as lecture materials on online learning platforms and in university courses. This lesson and the provided material should not be used to train an AI algorithm or a large language model. Before we start with C++ implementation, we need to clearly define a linked list. A linked list consists of nodes that are linked together by using pointers. Next, we need to define a node. A node in a linked list is a data structure consisting of stored data or a data object and a pointer to the next node in the linked list. Stored data can be integers, floats, strings, objects of classes, arrays, images, even other classes, etc. Over here you can see an illustration of a node. As explained previously, node is a data structure. It consists of two blocks or two parts. The first part is the stored data, and the second part or the second block or the second entry is the pointer to the next node. It's very important to keep in mind the following. This pointer over here points to the memory location of the next node in the linked list. That is, the pointer contains the memory location of the next node in the linked list. Similarly over here, this arrow represents the pointer from the previous node in the linked list, and this pointer points to the memory location of this particular node. In this tutorial, we'll call the pointer to the next node as link, and in this tutorial, whenever you see a link, you know that it's a pointer to the next node in the linked list. To properly define a simple linked list, we need to declare a head pointer of the type node. We call this head pointer simply as head in this tutorial, and this head pointer or head is illustrated over here. Note that head is not actually a node, it's a pointer to the first node in the linked list, that is, to this node over here. To summarize, our linked list doesn't start with the first node, instead, it starts with the pointer to the first node in the linked list. The link of the last node in the linked list should be a null or a null PTR pointer. This pointer denotes or marks the end of the list. In this tutorial, we will use null PTR to mark the end of the list. Note that null PTRs are actually introduced in C++ standard that is relatively recent. However, null is a notation that's used from the beginning of C++. However, since we want to keep this tutorial up to date, we will use null PTRs. So to summarize, over here you can see a linked list. This linked list contains 1, 2, 3 nodes. Nodes are actually data structures. Every node contains data and a link, or better to say a pointer, to the next node in the linked list. Then the linked list starts with a pointer called head, and this pointer points to the first node in the linked list. The linked list ends with the null pointer, and this means that this is the last node in the linked list. As you will see later on, we will use the fact that the list ends with null pointer to print all the entries of the linked list. There are at least two approaches to implement linked list in C++. We can use C structs or C structures and global functions. Then we can use C++ classes, and we will follow this approach in this tutorial. And of course, there are also other approaches for implementing linked lists. These other approaches are for more advanced users. Linked lists are dynamic data structures. Nodes are created by using the new operator and returned pointer. A pointer points to the node object and not to the data objects stored in the node. This is very important to keep in mind, since some students think that a pointer inside of a linked list or a link points to data stored in the next node. No, that's not the case. A pointer points to the node object and not to the data object stored in the node. We can expand the list by adding new nodes or shrinking the list by erasing some nodes. And as is mentioned previously, the address of the first node in the linked list is stored in a separate pointer of the type node that is called head. It's very important to preserve the address of the first node in the head pointer, since otherwise we might not be able to access particular nodes in the linked list. That is, once you start building the list, always make sure that the head, that is the head pointer, points to the first node in the list. Otherwise, if you lose that address, that is, if the head, for example, points to the second one or the third one, you will not be able to access the first or any other node in the list that's in the chain before the head pointer. Okay, let's start with coding. In this video tutorial, we will be using Visual Studio Code to implement our node class and our linked list, as well as the G++ compiler. Consequently, if you don't have a G++ compiler, it's very easy to install G++ compiler. I created a separate video tutorial on how to do that, and a link will be provided in the description below this video. So open a command prompt and make sure that G++ is installed. You can check that by typing where G++, and you should see the path to your G++ compiler. In my case, I installed the G++ compiler by installing min.gw, and the video tutorial I created will explain how to install min.gw. So, another thing to verify is to verify the version. Let's write this. And you can see that currently I'm using G++ or GCC 13.2, and this is basically a port of GNU compiler to Windows operating systems. Good. Next, I will be using Visual Studio Code. However, I will be using Visual Studio Code just to type things, since Visual Studio Code is very nice for typing code. I can also compile this in Visual Studio Code. However, I'm not going to do. I like to compile from the command line. So let's start Visual Studio Code. Here it is. And let's create our new file. First of all, I will create a header file of my node class. So consequently, I will click on File, New File, and I will call my header file simply as node.h. So let's press Enter, and let's store it in this folder over here. And here it is. Let's write the header file. First of all, we need to implement guards. These guards are used in the case if a user tries to include twice node.h in some other file. Namely, the guard will prevent that and this file will be only included once. Next, we need to include the library called CSTDDEF. This library defines and enables us to use the null pointer, which is denoted like this, null PTR. Okay, let's start with the class declaration and definition. I will call the class as node, and let's specify public over here and private. The node class has two private member variables, and they are stored data and a link. In our case, for simplicity purposes, the data will be simple integers. That is, I will type int over here as a data type, and I will call the private member variable simply as number. And we need to define a link. So let's define a pointer to our class type, and I will call the pointer as link node. Here it is. Next, let's start with the default constructor. Here it is. This default constructor will set number to 0 and link node to simple null pointer. I will implement it later on. Over here, let's declare the overloaded constructor. And let's type this. We will have over here int number store, and we will have this pointer over here, pointer node. This overloaded constructor will set number to be equal to the number store, and it will set the link to be equal to the pointer node. That is, the user can use the overloaded constructor to immediately set the number to be stored and to set the link to the next node. Good. Let's continue. Next, we need to declare setter and getter functions. So let's declare the function that will set the number. Over here, this function will return void, and it will be called set number. Inside, we will have as input parameters number store, and this function will simply set number to be equal to number stored. Over here, I'm passing by value, and I can do that since I'm storing integers. However, if you're storing some other objects or large objects containing a lot of private member variables, it's a good idea to pass by reference. Then we need to set the link. So I will call the function void set link, and over here the input will be node pointer node. This function will set link node to be equal to pointer node. Then we need a getter function, get the stored number, and this function should return integer, get number, and it will simply return the stored number. Then we need the function to get the link, so we will need to return a pointer to node, and I will call this function get link, and that's it. So let's repeat the complete class and let's summarize what we wrote. Our class node will have as the private member variables data that we want to store. In our case, we will be storing integers, and over here it will also contain a private member variable that will be a pointer to node. This pointer will store the address of the next node in the linked list. Then we will have the default constructor. The default constructor will set number to 0 and link node to null pointer. This overloaded constructor will store the number to this provided number over here, and it will set the link to this provided address. Then we have the number that will set the stored number, the function that will set the link. Then we have the function that will get the stored number, and we have the function that will get the stored link. The next step is to define the implementation file. Over here, let's click on File, New File, and I will call the implementation file simply as node.cpp. And let's save it over here. Over here, it's very important that the name of the implementation file matches the name of the header file. Let's go back here and make sure that the header file is saved. And over here, the first line is to include the header file. Here it is. Now go back to the header file. This is why I like Visual Studio Code. Namely, I can simply write a template for the implementation of particular functions inside of my class by simply selecting the particular function, then clicking here, and then click on Create Definition of Node in Node.cpp. And here it is. It will write the template automatically. So let's go back to the header file and let's copy this part over here. Let's erase this declaration. And over here, the default constructor will set the stored number to 0 and the link node to be equal to the null pointer. And that's it. Let's save this file and let's continue with the overloaded constructor. I will simply select it, go here, create definition, and inside over here we will do this. The number will be equal to the input parameter number, and the link will be equal to provided address stored in this pointer over here, and that's it. Let's continue with the set function. Select the set function, click here, here the template is created, and over here we need to type this line over here, simply as that. Let's go back and let's do the same for the set link, create definition. Set link will actually do this. Let's save the file and let's continue. Now we need to implement get number. Over here we need to return the number. Let's save this and let's continue. Then let's select get link and let's create definition. Over here we will return link node. And here it is. Let's save this. And here is the summary of the implementation file. All the functions are being implemented. Good. The next step is to write the driver code that demonstrates how to use our class. For that purpose, let's click on File, New File, and I will call the file as main file.cpp. And let's create file. Here it is. Let's start with the standard includes. I will need input-output stream since I plan to print the entries of my defined linked list. Then over here I need to include node.h, and then I need to type using namespace std to simplify the notation. Here's my int main function, and over here I will return 0. In the sequel, we will first graphically explain how to create a linked list, and then we will implement the code. The first step is to create a pointer of the type node. That is, the first step is to create the head pointer. And we do it like this. First of all, we declare the head pointer. It is of the type node. Then over here, we say head is equal to new node. What's happening over here? Well, to understand this, we need to look into the default constructor. So let's go back to the code and let's look at the default constructor. Once we call new node, a memory will be reserved and a pointer to new node will be returned and stored in a head. At the same time, a default constructor will be called. The default constructor, as you can see over here, will set the stored number to 0 and will set the link to be null pointer. And that's precisely what's happening over here. And after that, we set the stored element inside of our newly created node to be equal to 1 by calling the function setNumber, that is by calling the setter function defined over here. Now let's analyze this notation once more. First of all, since head is actually a pointer to the first node, we need to use these arrows over here. That is, we cannot write dot over here. We need to use an arrow, and then when typing this, we are actually calling the setNumber function of our node, which sets 1. Another thing to notice over here is that new node returns a pointer. And again, head is not a node. Head is the pointer to the first node. Okay, let's implement this. First of all, let's declare a head pointer. The head pointer is of the type node. Next, let's type this. Head is equal to new node. This code line will reserve a memory space and it will return a pointer to the newly created node in the memory space. This pointer will be stored in head. At the same time, the default constructor will be called. Again, here is the default constructor. It will set the stored number to 0 and it will set the link to be equal to null pointer. After that, let's store the value. Let's call setNumber and let's store number 1. And that's it. The next step is to create a new node and to link this node to our existing linked list. To explain how to do that, I again need to resort to the graphical explanation shown over here. First of all, we need to create a new node. As mentioned previously, we will create new nodes by calling new node. This will reserve memory space and it will return a pointer to the newly created node. At the same time, it will call the default constructor, and this default constructor will set the stored value to 0 and it will set the link to be equal to the null pointer. On the left hand side over here, I'm declaring a temporary pointer called node temp pointer, which will store the address of the newly created node. And the situation will look like this. We will have our temporary pointer, which points to the newly created node in the memory space. Next, let's set the stored number. To set the stored number, we simply need to refer to our newly created temporary pointer and call setNumber. This will actually call the setNumber function of our newly created node, and it will set the value to 5. The next step is to link this node to our linked list. Our linked list is only head and a single node. And let's learn how to do that. First of all, new nodes in a linked list are always placed at the top or at the beginning of the linked list. In our particular case, this node will be placed before or at the top of our first node. The process of linking, or better to say, the process of inserting our newly created node to the existing linked list consists of 2 steps. In the first step, we set the link of our newly created node to be equal to head. By doing that, this link over here will point to the first node in the linked list. We perform this operation by using this statement. We type node temp pointer, then right arrow set link head. This C++ statement will call the setLink function of our newly created node, and it will set link to be equal to head. After performing this operation, the situation will look like this. Over here, our new node is placed at the top of the linked list, and this is what we want. Now, its link is not anymore the null pointer. Instead, its link points to this node over here. This node was previously the first node in the linked list. However, the issue over here is that the head pointer still points to the previous stop of the linked list, and we want head to point to this node over here. So how to do that? Well, we can do it by using this C++ statement. We simply say head is equal to node temp pointer. By executing this code line, we will now obtain this situation. Now head will point to the top of our linked list. That is, it will point to our new node that's placed at the top of the linked list. And we are done. This is what we want. Let's implement this in C++. So let's create a new node. Over here, I will type this. First of all, I will declare a temporary pointer, node temp ptr, and this pointer will be equal to new node. New node will create a new node, and it will call this default constructor, and it will return a memory address, and this memory address will be stored inside of this pointer. At the same time, this default constructor, as you can see over here, will set the number to 0 and the link to be equal to the null pointer. The next step is to set the number. So now, to set the number, we simply need to type this, node temp pointer, then let's do the right arrow and let's type set number, and over here let's store, for example, 5. Next, we need to link the new node to the list. To do that, first of all, we need to do this. We need to type node, temp pointer, then the right arrow, then we need to type set link, and we need to pass head. So let's now look into set link function. Here it is. This set link function will assign our head to link node, and now the link will be pointing to the first node. After that, we need to move the head. Head is equal to simply node temp pointer, and that's it. We inserted the second node. Next, as a practice, let's add a new node to our linked list. We want to add the new node at the top of the linked list. And to do that, we need to repeat the previous steps. Here they are. First of all, we need to create a new node and to return a pointer to that new node, and this node, or better to say, this pointer will be stored in node temp pointer. Then, after doing that, let's set the stored number to be equal to 10. Then let's link this new node to the first node. We simply called node temp pointer set link. That is, we call the set link function of this node over here, and we pass head. Now what will happen is our new node, or better to say its link, will point to this link over here. However, we still need to move head, so we need to type head is equal to node temp pointer, and as the result we will obtain this situation. Here's our new node. Head now points at the top and everything works fine. And after this, you don't need to keep node temp pointer, you can simply set it to null pointer. So let's add a new node. Add the third node. Over here, we don't need to declare again node temp pointer since we did it over here. We can simply type this, node temp pointer is equal to new node. Then after that, let's set the stored value. Let's store 10 over here. Then let's link this node by calling node temp pointer set link, and let's pass the head. And after that, let's move the head. Now head should be equal to node temp pointer, and that's it. And over here, we don't need the node temp pointer anymore, so I will set it to null pointer, and that's it. Now let's make sure that everything is saved. Save node.h, save node.cpp, and save mainfile.cpp, and let's try to compile this code. Of course, nothing will be printed out. I'm just trying to compile and to see if there are some compiler errors. To compile everything, make sure that you're in the base or the workspace folder, and over here simply type this g++ star.cpp. This means that we want to compile everything, and we are specifying the output file, which will be our executable. So let's run this, and no compiler errors. So let's now type output to see, can we execute the file? We can execute the file, and of course nothing is printed out, but at least there are no compiler errors, which is good. The next thing that we need to learn is how to iterate through the nodes of our linked list and how to print every entry that's stored at a particular node. The idea over here is relatively simple. First of all, we will declare another temporary pointer, we will set it to head, and then we will simply iterate through this list, and we will print the entries, and we will stop once the next link or the link stored at a particular node is a null pointer. That is, the stopping criterion is when the link is equal to the null pointer, this means that we reach the end of our linked list and we should stop the iteration. Let's implement this in C++. First of all, I will declare a temporary pointer that will be used to traverse the list. And I will call this pointer as current link. After that, I will write this. Current link is equal to head. That is, at the beginning, current link will point at the top of our linked list. That is, the current link will point to the first node inside of our linked list. Then I will declare a counter and I will set it to 1. Counter will count the number of nodes. We start from the first node. Then I will write a simple while loop that will be used to iterate through our linked list. And over here as the condition I will type current link not equal to null pointer. This while loop will be iterated and executed until current link becomes null pointer. That is, if current link is not equal to the null pointer, this while loop will be iterated. Why I'm using this statement? Well, if we go back and if you look at our linked list, we can see that the link of the last node is null pointer. That is, once the current link becomes the null pointer, we know that we reach the end of the linked list. And over here I will type cout for printing, and let's print this. Element stored in node, and let's retrieve the node number. Let's type counter. Then we need to type is, and then over here we need to do this. We need to type current link, then right arrow, and we need to call get number to retrieve the stored number, and after that we need to end the line, and that's it. Simple as that, nothing special. However, the while loop doesn't end here. First of all, we need to increment the counter, and then we need to do the following. We need to change the current link. That is, the current link is not anymore pointing to our current node, it points to the next node. To do that, we simply need to type current link is equal to current link, then the right arrow, get link. So what will happen after this statement is that current link will be pointing to the next node. And we retrieve the next node by calling current link, get link, and getting the link, that is getting the address of the next node. And in the next iteration, current link will be actually pointing to the next node. And this is how we iterate through our linked list. Simple as that. Next, let's save this file and let's compile this project. To compile the project, let's go back to the terminal. Let's make sure that the dates are correct. They are. And then again, let's execute this command to compile everything. No errors. And let's see the output, and let's try to run everything, and let's see. Here it is. Element stored in node 1 is 10. Element stored in node 2 is 5. Element stored in node 3 is 1. Now, to analyze this code, it's a very good idea to go back and to see what we wrote over here. Let's go back to the top of our code. Over here we created the first node. However, over here we can see that this node is at the end of the linked list. This is the direct consequence of the fact that new nodes are added at the top of the linked list. That is, the first entry that's added or inserted to our linked list will be at the end. And then you can see the second element or the second node, it's here, and the first node is actually the node that we add or inserted the last one. Keep in mind that. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons and see you in the next video tutorial.